we're going to start looking at angles and trig functions on the unit circle. What we're going to start with is this. Suppose you have any point on the unit circle, all right? Like, for example, the point 4, 3, right? So here we go, 4, 3, I'm right there. And if I draw a line or maybe a ray from the origin to that point, right? All of a sudden, look, I've created an angle right there between the x-axis and that ray that I just drew. Now, in trig, it's all about the radius, okay? So that ray, I call it R for radius. And now all of a sudden, I've got an angle there between the x-axis and the radius, all right? And anytime I've got an angle, I can create a triangle. Yay. Boom, boom, yay is right, okay? And just so happens, it's a right triangle, even more yay, double yay, okay? And when we have right triangles, what's our favorite thing to do with them? Sine, cosine, tangent, of course. Yay. So now, very quickly, I could figure out the sine, the cosine, and the tangent. Well, let's explore a little bit. In order to get from the origin to that point, we'll call it P, right? How do I get from the origin to that point P? I have to go over horizontally a little bit and then up a little bit, right? How much am I going over horizontally? Horizontally along the red, I'm going over 1, 2, 3, 4, and vertically, I'm going up 3. My point is at 4, 3.
No way. I don't know what I will.
So I need to go over horizontally 4 units and up 3 units. And so now I know how much those are. If I only knew how much the green radius is. Pythagorean theorem, oh my gosh. So we do Pythagorean theorem. And have you guys seen a pattern yet with a right triangle with legs of 3 and 4? What's the hypotenuse always?
5.
It's always a 5, right? You can do Pythagorean theorem and, you know, it'll tell you that it's also a 5. Now that I have this, can I find the sine of that angle theta? SOHCAHTOA, right? Sine is always opposite over hypotenuse, adjacent over hypotenuse, and so on, right? So sine is going to be the blue over R, right? And if my point was at 4, 3, and if that's x and y, the 3 is that same y value from the coordinate point. Do you see it? And the x is that same x value from the coordinate. So if I wanted to find the sine of that angle, it'll just be y over r. And if I wanted to find the cosine, it'll just be x over r. Cosine, remember sine is opposite over hypotenuse, y over r. Cosine is adjacent over hypotenuse, x over r. So now I could abandon SOHCAHTOA, and I could just say sine is y over r, cosine is x over r, and how much would tangent be? With this. Y over x, right? Y over x. And now if we come here in this chart, oh my God, look at that. They came up with the same thing that we just did.
What?
Sine, no. Sine is y over r. Cosine is always x over r. Tangent is always y over x. And then once we have those, they're little buddies. Cosecant, secant, cotangent are the reciprocals. So x over y over r becomes r over y, and so on and so forth. So with this, we could do this for any old point. And oh my gosh, the first point I have here is the same, 4 over 3, right? So if we were to go with that, 4 over 3. Now, I draw it for the first couple of times. The diagram is really not necessary if you want to, because you want to see it visually, fine, but it's not really necessary. So this is 4 and this is 3, and I need to find r. For r, I can do the Pythagorean theorem. Okay? On the quiz or test, you could do the Pythagorean theorem. You could show me that r equals 5. Or if you could just recognize that it's a 3, 4, 5 triangle and just write down r equals 5, I'll take that too. Okay? So now, sine will be 3 over 5, cosine 4 over 5, tangent 3 over 4. Right? And we do these same way. Okay. This is sort of the more boring example. Are there any questions on this one? All right, let's take it up a notch. Here we are at -2 and -1, right there. Okay. And I need to find r. Well, r squared, if this is x and y, is -2 squared plus -1 squared. All right. So r squared is 4 plus 1, 5. So how much is r? Root 5, positive root 5. Okay. Now, for sine, we said it's always y over r, right? So I don't even need the diagram. Here is x, here is y. Y is -1. R is 5, and there you have it. Okay, so you could just go off of that. Cosine is x over r, -2 over root 5. Tangent is y over x, negative what? -1 over -2, so that's just a half. And then for their buddies, we just flip. So negative root 5, negative root 5 over 2, and 2 over 1, which is 2. Does that make sense? Yeah? All right, cool. So now, this is all fine, but you know, if I were to pick any random point, yeah, it could be inside one of these quadrants, but if I pick any random point, close my eyes and pick a point, it could also fall right on the axis, right? When the terminal side falls on one of those axes, that angle has a special name. What is it? It's a quadrantal angle. Okay? When it's a quadrantal angle, okay, in this case, choose a coordinate point. Okay? All right. Suppose my point is here. Can you come up with a sample coordinate point for that position? Like, it can't be 1, 5. Could it be 2, 0? Yeah, 2, 0 could be here. 70, 0 could be there. Really anything, 45, whatever you want, right? Now, suppose that was 2, 0, okay? X is 2, Y is 0, right? Remember we were talking about R? R is the distance from the origin to that point. In this case, how much is R? 2. It's the distance from the origin to that point. In this case, it's 2 units, right? So R is 2.
So R and X are the same?
R and X are the same. And that's really the point I'm getting to. What if I didn't choose 2? My favorite number for these is a 1. What if I chose 1, 0? What would R be then?
1.
Just 1. And so now, if I wanted to find, let's say, how much is the angle at that point? 0, right? It's 0 degrees. If I wanted to find the sine of 0, it would be y over r. Y is 0 over r, 0. Okay? What would the cosine of 0 be here?
1.
1.
0, so it's undefined.
Ooh. Is it 1 over 0? So it's
1
x
over
over
5.
r, 1 over 1, 1. So cosine is x over r. Yeah? So here, cosine is x over r, 1 over 1, so it's just 1. Okay? Right. So why don't we do some of these here? Let's do cosine of 270. So here's how I do it. Where is 270? Right, left, top, or down?
Down.
Top or bottom? Bottom here. What would be a good coordinate point there?
0.
0 and 1 or negative 1?
Negative.
Negative 1. And then r is always going to be 1 for these. Okay, so now
I thought R was always
It's the distance.
it's the distance. Oh my. It's the distance. Okay? Okay, so sine of 270, we want cosine of 270, right? How much is cosine of 270? Then that's x over r, which is 0 over 1, 0. Okay, so just for fun, why don't I have you go and do all 6 of these? Because why not?
Wait, 6?
Yeah, no, like just for 270, sine, cosine, tangent, cosecant, secant, and cotangent.
No, we don't know what hypotenuse.
You mean the radius? We're calling it radius, which is 1 in this case. So why don't we go ahead and do these? Who came up with a sine of 270? Anybody? I have a negative 1. It's y over r, negative 1. Cosine we said was 0. Tangent is y over x, so how much is that going to be? Negative 1 over
0, so
0.
0.
Okay, that's undefined. The secant is also undefined because it'll be 1 over 0. Cosecant will be negative 1. What about cotangent? 0 over negative 1?
0.
0.